This lesson continues our topic on trigonometry. We're moving on to learning target 2. Remember, last time we were on learning target 1. It covered how to use the Pythagorean theorem to solve for sides of right triangles. But today we're going to focus on learning target 2. Learning target 2 is going to cover something very specific. It's going to cover what are called special right triangles. We're going to find the important pieces of special right triangles and use those important pieces to figure out the missing sides of these triangles. In order to do that, we are going to have to get a little familiar with how to simplify radicals. The square root symbol is a radical. There's lots of radicals, but in our class we're only ever going to use the square root. The way that you simplify a radical, the way that you simplify something being square rooted, isn't to just type it into the calculator. Not all numbers are going to come out to a whole number when you square root. So how do we simplify 18? Well, we think about two numbers that multiply to make 18. That could be 9 times 2. Why did I choose 9? I chose 9 because 9 is a perfect square. If we square root the 9, we get a 3. I am not going to square root the 2. That leaves the 2 underneath the radicals. Let's try this with the 60. What times what makes 60? 4 times 15 makes 60. Again, I like writing down the 4 instead of other numbers, such as 6 and 10, because 4 is a perfect square. Square root the 4, you get a 2. We will not square root the 15, it stays inside. Let's work on this one. Square root 80. The square root of 80 divided by 8. Let's work on the square root 80 first before we try to divide by 8. We cannot just do 80 divided by 8 and make it 10, because the 80 is underneath the square root sign, but the 8 is not. So let's first break down the 80 into something times something. Again, I could write down 8 times 10, but 8 and 10, neither of those are perfect squares. I'm going to write down 16 times 5 instead. The square root of 16 is something I can square root, and 5 is something I'm not going to square root. So the square root of 16 is 4. Square root 5 is going to stay the same, and we're going to put the 8 underneath. Now I can reduce the 4 and the 8. Both of them can reduce by 4, so I'm going to divide the top and bottom. I end up with square root 5 over 2. If you do not know your perfect squares, I suggest that you write them down as a list in your notes. Your perfect squares would be 1, 4, 9, 16, 25, 36, and so on. Now let's get into these special right triangles. The first special right triangle is a right triangle that has two equal angles. The two equal angles are 45, 45. So we refer to this as the 45, 45, 90 triangle. Why is it special? Well, because there's properties about its sides we can always use. So what I want you to do right now is drop your pencil and just watch me create the sides of this triangle. Let's say that the first side of this triangle is 1 long. Since there's two equal angles, there has to be two equal sides. So this would also be 1. To create the last side, I'm going to use Pythagorean theorem. 1 squared plus 1 squared equals c squared. 1 plus 1 equals c squared. 2 equals c squared. So c is equal to the square root of 2. So now I'm going to put that on my hypotenuse. Now this is nice for this triangle, but it's not really helpful in other situations where we have a bigger or smaller version of this triangle. So what we're going to do is, let's say that instead of a 1, this 1 is a 1 in. That means this side would also be 1 in. And that means the square root 2 would be an in square root 2. So in essence, I have multiplied all the sides by an in. This gives me formulas. Okay, now I want you to pick up your pencil and copy down these formula sides of the 45, 45, 90 triangle. Okay, let's try using those sides on these sides to try to figure out the missing u and v. So the 7, it gets our n. The 7 is equal to the n. The v is also on the same side where there was an n, and the u was on the same side as an n square root 2. Notice how I write these all as little mini equations. So let's write these separately. I now know that n is equal to 7. I know that v is equal to n. And I know that our u is equal to n square root 2. So if I'm going to figure out v or figure out u, I have to know what goes in this n spot. Well, lucky for me, the problem told me what n is. So I plug these into these spots and I rewrite my answers. So v is equal to 7. There's one answer. And u is equal to 7 square root 2. There's the other answer. So if you have memorized the important sides of a 45, 45, 90 triangle, often the problem just tells you what number to plug into each of the formulas for each of the sides. Let's try a little bit harder problem. In this problem, I'm going to start off again by writing down what each of these things equal. The y is on the side as the formula for n. The x is on the side with formula n. And the 18 is on the side with formula n square root 2. So if I can figure out n, I will figure out x. And if I can figure out n, I can figure out y. The problem is this triangle does not straight out tell me what n is. Instead, it only tells me that the 18 is equal to n square root 2. So how can I solve this for n? How can I get n by itself? Let's multiply both sides by something that will transform this 2 into a perfect square. Well, a perfect square would be 4. So let's multiply this by another square root 2 to turn this into a square root 4. What I do to one side, I also have to do to the other. So now what I have is 18 times square root 2 on one side. And on the other side, I now have n square root 4. I can square root the 4 and get a 2. So this is n times 2 now. I can divide by 2 and get my n by itself. So my n will be equal to 18 divided by 2 is 9 with a square root 2. Notice how the square root 2 follows down along the left side of our equal sign all the way to the end. It's never actually affected by any of our other processes. Now that I know what my n is, I now know what my x and y are, since they're both equal to n. So my x is a 9 square root 2, and my y is also a 9 square root 2. They both have to be the same thing because they're the two sides of the 45, 45, 90 triangle that are the same. Go ahead and try out these two problems. Pause it, try them out, and then unpause it to check your answers. Okay, here's my answers. If you did not get my answers, I'd like you to pause the problem and raise your hand, and I'll come and check in with you and figure out what's going on. Our second and also our last special right triangle is a right triangle that has a 30, a 60, and a 90 angle. So just like last time, I would like you to put down your pencil and just watch as how I create the special formula sides for this special right triangle. I'm going to start out again by picking one of the sides to just be a basic measurement of 1. How about the smallest side? So across from the smallest angle is my smallest side, 1. If I were to measure how long this side is, in reality it's about 8. How long is the hypotenuse? Ooh, it's about 16. That's pretty interesting. That means that it is twice as big as whatever is on the shortest side. So since it's twice as big, it would be 2 in this problem. Notice that the biggest angle is across from the biggest side. Now how do I find the last side? Well, let's use Pythagorean theorem again. 1 is A, I'm trying to figure out B, and my C is 2. 1 plus B squared equals 4. Let's minus 1 on both sides and get 3, and then square root. So I end up with a square root 3. So across from the 60 is my square root 3. So these are the special basic sides, 1, square root 3, and 2. I know it looks like the biggest number is not on the biggest side, but if you were to square root 3, you would get a number that is in between the 1 and the 2. It is not actually bigger than 2. 2 is still the biggest number we see right now, and it's on the biggest side, the hypotenuse. But just like before, we want to have this look like more like a formula. So instead of being 1, it's going to be a 1n. And instead of being 2, it's going to be 2n. And instead of being square root 3, it's going to be n square root 3. So I multiplied all my sides by a square root 3. Pick up your pencil and copy down these special sides, because these are the formulas. Let's use these new formulas to figure out the x side and the y side of this 30, 60, 90 triangle. The 10 is on the side that would be the n side, the smallest side. Remember, smallest angle, smallest side, that's n. The 60, which is the middle angle, because it is in between 30 and 90 in number, is across from the middle side. That is my n square root 3. And across from the 90-degree angle, the largest angle is the largest side, and that is 2n. So my problem has presented me with this information. I know that my n is equal to 10. I know my y is equal to 2n. And I know that my x is equal to n square root 3. So the problem has told me what n is. It's 10. Let's go ahead and plug it into both of these spots and get our answers. So my y is equal to 2 times 10. My y is equal to 20. And my x is equal to 10 square root 3, which is as simple as it gets. I cannot do anything with this. So I doubled my 10 to get my longest side, and I plugged it in next to the square root 3 to get my middle side. Sometimes you might be presented with a situation where there's already a square root with a number in the problem. Don't be afraid with these. Sometimes it's still a rather quick and easy problem. We have to make sure that we're labeling it correctly, and then maybe the problem will just tell us what the things are. Start out with the shortest side. The 30 would be here, and across from it is the y. So that would be my n. 60 is always across from the n square root 3, so this would be n square root 3 here. And across from the 90 is the biggest side, which is the 2n. So this problem has told me that my y is equal to n, my 3 square root 3 is equal to n square root 3, and my x is equal to 2n. None of these tell me write out what n is equal to. So let's work on this one here, since both of these need something plugged in. Both of these have a square root 3. Since they both have square root 3, let's divide both sides by square root 3. Ah, look at that. I'm left with a 3 and an n. I now know what my n is. Let's take it and let's plug it in to each of these spots. So y is now equal to 3. That one's finished. And my x is equal to 2 times 3, which is 6. And now that one's finished. So it wasn't too hard to figure out what the n was. There was just a 3 in that n spot. So for this problem, the n was 3. Use it in the other two sides to figure out your two measurements. Okay, let's start to set up this problem. Our n is our n. Well, that's nice and easy. Our m is our 2n, and our 6 is our n square root 3. So let's write down what the information is. I'll know n when I have figured out n. So I'm just going to put a number here once I figure it out. I'll know m once I can double it. So I'll put a number in here and times it by 2. So the only thing I have to work with is this 6 equals n square root 3. This solved will give me the n I have to plug into our other two parts of our triangle. Kind of like with that 45-45 example, there's a square root 3 next to the n. I don't really want to divide it because then it'll be underneath the 6. Instead, let's transform it into a perfect square. If it were a 9, I could square root it. So let's multiply it by another square root 3 to transform it into a 9. Don't forget to do it to both sides of the equal sign. I now have a 6 square root 3 to the left of the equal sign and an n square root 9 on the right side of the equal sign. Square root 9 has an answer, n times 3. To make that 3 go away, I'm going to divide by it. 6 divided by 3 is 2, square root 3 equals n. So I figured out my n. If I figured out my n, I have definitely figured out this side. But I do still need to put it into the 2n so that I can double it and figure out the m side of my problem. So m is equal to 2 times 2 square root 3. Don't get too freaked out about this. It's a lot easier than it looks. 2 times 2 is 4. The square root 3 does not get affected by the 2. It is inside a square root sign and therefore does not get multiplied. So there's my two answers. Okay, go ahead and you try these problems. Pause the video and then unpause it once you're done to check your answers. Okay, compare what you got to what I got. I got an x equals 9 square root 3 for the first problem, and for the second problem, I got a 4 square root 3 and an 8 square root 3. If you didn't get these, raise your hand and call me over if you need some help. Okay, let's revisit our scale to see where we're at and where we're going. Where are we at? You've already had a lesson on learning target 1, Pythagorean theorem. You just had a lesson on learning target 2, special right triangles. So we're still only working on level 2, which is foundational. We have one more lesson to do, which is going to cover trig ratios, and that's going to be our next lesson. After we're done with that, we can finally start the work on the level 3 work. Don't forget to hit the submit button underneath the video so I have record of you watching it.